Yes.
And then for a 0 is the size, right? Like .b or .word.
Yes, 0 is the size. That's correct. .b, .w, .l. You can just store a B, W, or L. That's easy enough. So you have your main method in it. It's just the same. And you're going to comment out or remove this print macro call so that that doesn't go to the screen. Okay. Late programs will be accepted, but recognize that we're at the end of the semester. In the following week, we have class, but that's the end of the line. So it can't go beyond that, or we won't have any ability to get it graded on time. I won't have. Besides the which, when you're losing 5% per day, that's kind of a killer. So I have kind of been flexible about submission times up until now. But for this last project, I will make the deductions for late programs. I will do that. So please try to get this done on time. You know, it's a little bit harder when you have groups, and I recognize that. Some of you have been enormously frustrated dealing with groups. And it's made worse by the fact that you're not all in one place physically. I mean, it's true, if you're working at Qualcomm and you're part of a group, then presumably the group, they're all on site during normal working hours. I mean, one guy might have to get on a plane and go to Phoenix or something, but by and large, the group is there and available. And with you guys, it can be a little bit different. You have work schedules, other classes, and it can be difficult to find times. I understand that. But find a way to make it work. Okay, so big chunk here, and an important one. Are there questions for you guys? So what you have to do is really pretty straightforward and unambiguous. What I suggest you do is start early on it rather than late. You know, it's a bear when you run out of time and you got no place to go. You have a project due and the deadline is looming large and there's no way you're going to get it done in time, and that's an awful feeling. At least it was for me when I was a student. And I'm assuming that hasn't changed. So any further questions on this? Yes?
It's not about the program, but for next week, what's the schedule? Like, we're going to have class on Wednesday? Or?
No, we're not. There's no class on Wednesday.
Oh, there isn't, no.
That's in the official schedule. Campus is open, but there's no class. And I'm assuming you guys are not going to stick around, so I won't have office hours on Wednesday either, because I'm assuming no one will be here. I know how it was last year. We had class on Wednesday and nobody was here. If you shoot a cannon down the boulevard out there and not hit anyone. So I don't plan to be here Wednesday. I'll be in town. I'm not going anywhere, but I know a lot of you guys don't live here in San Diego. And historically, a lot of students will leave Tuesday night or even Monday night, Sunday night, something. At any rate, we will have class Monday. Now on Monday, what we're going to do is review for the exam, which will then be the next Wednesday. So I like to do it. I don't want to wait till 2 days before the exam to do the review. So on Monday, we will do an exam review, and I'll try to give you good guidance about what to study for the exam. You already know some of it. I'm going to ask you to do the things that didn't work well on the last test. So you're going to have to do hand translation to assembler. Yes?
How about code debugger? Like, debugging code?
Debugging code. I don't think I'm going to do that. I don't think I'm going to give you C++ code on this test. I'd probably put some on the final. But on this test, I think I want it to be shorter and more focused. And so I'll give you a short list of things that you have to study for or will want to study for before the test. So, okay. So I gotta do the groundwork here before we do this exercise. So a few things to talk about. We have seen expressions in assembly language code, and we really haven't talked a whole lot about them. Did I turn a light off? I think I did. Which one is it? Wrong one. Okay. So assuming that these labels are valid and exist, is that a valid expression? So we have a label called buff. What's buff plus 2? What's the value of buff, or whatever it is, plus 2? Well, it's presumably the address. Is that valid? Valid or invalid?
Valid question?
Valid.
No.
Invalid.
IPK?
How about that first one? Is that okay? Well, can you use
Yeah.
the times and the divide at all in an expression? The answer is yes, you can. They can be valid. Okay, the question then is, there are two expressions on the board. I've changed the first one. Is the first one valid?
Yes.
Yes, it's the same as buffer plus 6, isn't it? Okay, what about buff times 2?
The address on
What's wrong with it?
taking the address.
Maybe it goes out of bounds of the addresses we have.
It very well may go out of bounds, yes. Okay, so is there a way we can express what's valid versus not valid? I mean, how you can look at it and say to yourself, now wait a minute, this is gonna give me a really weird address. But the computer can't do that. Is there a set of concise rules we can deal with? So the first thing, one, expressions are either absolute or relative. Absolute or relative. So what is an absolute expression? What is the difference between absolute and relative? Anybody? Nobody. Absolute is an expression that is the same no matter where loaded in memory. Relative. This will change depending on where loaded. Okay, so the key to this is ask yourself, if I load this in a different place in memory, will I have a different result? That's the thing to ask yourself. So relative terms, relative occur in pairs. These must occur in pairs, or if they're not in pairs, then what is left? Or if an odd number, the remaining term must be positive. So these have to occur in pairs. Okay. End A minus start day. They occur in pairs. There's a plus and a minus. When I say pairs, I mean opposite sides. This one's positive, this one's negative. They cancel each other out. So end A minus start A gives you what? The number of bytes between the two addresses, the distance between the two addresses. So that makes sense. So imagine we have something that looks like this. Start a word 10, end a word 2. Okay, so what is end A minus start A? It's 3. We don't know what the addresses are. We don't care what the addresses are. This allocates 3 bytes, so we have there's the 10. This is start A. And this is end A. So it's a 2. So whatever these addresses happen to be, wherever you load it in memory, isn't the difference always 3? Sure. All right, so that's the pairing idea. So let's give these numbers here. Let's say this is 1,000. And this is 1,001. This one 1,002. This one 1,003. So 1,003 minus 1,000 is 3. Now if we loaded it in a different address, we have the same result. You with me? Okay. End A minus start A plus start B. Is that valid? So let's say start B is here, and it's a word, and it's 5. Okay, what is the result of end A minus start A plus start B?
6.
So this is the 2, and this is 5. This is start B. Okay, so what's the address? It's start B plus 3, isn't it?
It doesn't.
You see this, so does this work? Is this valid?
Sure.
Sure, this is valid. So this is end A minus start A plus start B. So what we have here is terms that are paired. They occur in pairs, a plus and a minus. Only we have a leftover. There's a remaining single term, and it has to be positive. Does it really? Okay, let's try something. Minus start B. Okay, we have end A, 1,003, minus start A, that's 3, minus start B, which is, what's start B, 3, 4, 5, 6. So what's that give me? A negative number. Can't be. Can't have a negative address. That's not going to fly. So they must be positive because it won't resolve to a valid address. Okay, can we have times and divide? Yes. Can we come up with a rule here?
Sure.
What's the rule? No or in relative expressions. Or maybe I should say sub-expressions. This first one here is okay. Because it's buff plus 6, same thing. That's okay. So if we look at it this way, which is how the precedence of the operators would occur, it is a relative plus an absolute, and that's okay. We have one left over after the pairing, and buff is positive. There is no pairing, of course, there's only the one token. But after the pairing, if there are more than one, then you take them and pair them. Okay. So, how do you tell if something's relative or absolute? Well, the question is, do you have any relative terms left after you're done? That is, if you can resolve the terms and remove them, if you have something left that's relative. So this turns into 3, which is absolute. So a relative minus a relative gives you an absolute. You with me? Okay. So you have an absolute, and then you have a relative. So absolute plus relative equals relative. So if there's any relative part of it, it's relative. So this all sounds very confusing. We have these expressions in our code, and we have to deal with them. Thankfully, you're not writing an assembler this semester. This was an extra credit portion last time for the students that did write an assembler. They had to handle expressions, and some of the people tried it and they had fits with it. Getting the rules to figure this out are not trivial and tricky. They're tricky, I mean. Okay. So, now I want to talk further about linking steps. And the text makes a distinction between 2 types of program segments. There are blocks and sections. And we need to be able to make the distinction between them. So blocks are within one object file. They're logically one piece. So you may have a separate piece of code inside of one source code file. So with blocks, the syntax is use. So there's a default block that's in play if you don't have a use statement. Then you have use, and then you give it a name. See data, for instance. What that means is, from this point on, until you either hit the end of the file or you find another use statement, you are in a separate block of code. So this can be used to organize the information manually that's in your file. For instance, if you have large data sections, it's often useful to make a separate chunk, and this helps when you do the linking and loading. You can use different locations so you can break this up more easily. Okay, so use CData turns on the block CData. Then, if you have another statement use and no name, it reverts back to the default block. You You with me? Okay, so you can have blocks of code this way. It's a simple idea. The other one is sections, a control section. And this is the more common case. This is in separate object files, but they need to be linked. So this is the most common way we do things. I don't think you guys ever do projects now that have only a single source code file, do you? I mean, are there projects that you do now at this point in your careers where you have only a single file? I mean, it would be very unusual. How many files have you got for project 2 in this class?
6 or 7.
You know, there's quite a few pieces, aren't there? Okay, so this is how you do it. And so you will segregate things into separate files essentially. But if you have a name in one file that doesn't exist in that file, exists somewhere else, then how does it mean anything and how does it make any sense? So we have to have a way of doing that. In the case of what you're working on now, suppose I have a call to strip in, say, prog.s. But there's no strip defined in that, but there is a #m include. Well, that pulls it in. Well, what would you do if you didn't have the #m include? You would have to link them. Do you know why we have that #m include? These aren't really used on other platforms. Why do we have that? Why the #m include? Yeah?
So we don't have to keep putting the macros in the same file.
Yeah, but couldn't we have them in separate files? Well, the problem essentially, and some of you aren't familiar with this environment, and I apologize for referring to it, but most of the CS students have done it with this way. But we use a simulator system and there's no linker and no loader. So there is no way to do this apart from doing this manually. You have to link things and load things manually, which means if you have 6 pieces, you have to load those, all 6 one at a time. As for the linking, you have to manually set up links between them, whereas this would be handled automatically with the linker loader, which we don't have with that simulator system. Okay. So you're parsing a file and you have strip. And without the m includes, well, there's no reference to strip here. How would it mean anything? So we have to set up global symbols or ways to link these parts together. So there are xdef and xref or similar statements that are used. Some of you guys have done a lot of C programming. Have you ever used an extern? Extern, not familiar? Okay, well, it's the same idea as this. So xdef is export the symbol. So when you're processing a file, you have a sim tab, a symbol table for all of the user-defined symbols in that file. But it's not global. It's not global. If I have label buffer in file A, can I also have label buffer in file B? Certainly. There's no name clash. Why? Because the symbol table for each file is local to that file. So what we need is a new symbol table for global references. So XDEF is export and XREF is import symbols. So what you do at the top of your program block, you say XDEF, and then a comma-separated list of symbols or labels that are referred to in other pieces of code. And then XREF says this block that we're in right now refers to the following external symbols. Does this make USB? So these then get placed into a global symbol table and they can be looked up. And then when you load, you have another problem. So I'm going to go ahead and pass this handout to you guys and we'll talk about it. Please ask me if you have questions about this. You should expect an exercise like this on the test when we come back from Thanksgiving. So we're going to work through this fairly carefully, make sure everybody's on board with this linkage step. All right. Backstreets? Okay. Now then. So I want to talk about this just a minute. Let's look at this. We have program A. It starts at 0. That means it's relocatable. And it has a certain number of symbols that don't exist in this program. So notice the second and third lines. We have XDEF, list A, end A. Okay, those are from this program. You have list A at address 40 and end A at address 54. Those addresses, of course, are relative to 0. They're relative to 0. They're not the actual addresses you'll have when this program is run. Then we have external reference list B, end B, list C, end C. So these 4 tokens do not exist in this file. So, looking at the code here, we have list A, all right? And so I'm looking at line 20. Line 20, LDA list A. Well, list A is in this file. And the 01D in the last column, that's the displacement. That's the distance between the current location and where list A is. The star here, you have list A EQU star. What that means is it gets the address. Okay, normally you would have something like list A EQU 8 or 10 or 50 or whatever. The star means it gets the location counter. You with me? Okay. So, we have expressions pound end A minus list A, and that goes in LDX, the X register. Can we resolve that expression in this file? In fact, we can. We subtract the difference. It's 54 minus 40. That's 14, or 20 bytes. Does everybody see that? So what the assembler can do, it does. The line above, list B plus 4. Now this is a format 4 instruction, so you have plus LDT, list B plus 4. Does everybody see that? How is it encoded? Well, the 5-digit field is 00004. Where'd that come from? The plus 4. That's known, so the 4 is encoded. But notice that this code can't possibly run because 4 is an invalid address. That doesn't refer to wherever list B is, so it will have to be modified. Notice on the bottom here, we have the modification records given. So at address 24 and 54, we have to change those values. So this list B plus 4 has to be changed, and how is it changed? We have to add the address of list B to it. And then the bottom one, end A minus list A, plus list C, we have to add the value of list C to it. You with me so far? Do you follow what has to happen? So if you do have questions, please ask me. You will have to do this, as I said. Next page, we have program B. Well, notice we have list A, end A, list B, end B, list C, end C. They came out of the book, but I liked this usage. I've adapted it because it's kind of simple. Okay, this is program B, so we're going to export list B and end B. That's going to go in the global symbol table. Then we're going to refer to or import list A, end A, list C, end C. So those are symbols that are undefined at this point, but we're telling the assembler these are in fact valid. If you see a list A, don't freak out, don't print an error message. It's going to be linked later. So here we have on address 36, plus LDA, list A. And what's the address given? 0. Well, how could it be anything else, because list A is not defined in this file? But understand, these are all assembled separately. These are assembled separately. They're separate object files. The next one, list B plus 4. Well, can we do that? Sure we can. We know what list B is, and we can add 4 to it. So there's nothing we need to do with that one. Pound sign end A minus list A. Okay, again, it's encoded as 0 because we don't know what it is. Now look at the modification records. There are 2 of them for address 3E. There are 2 of them. Add end A, subtract list A. Questions about this? Okay. And the bottom one. End A minus list A plus list C. None of those symbols are defined in this file, so we have 3 modification records. Now, is that expression valid? Yes, it is, because you pair up 2 of the relative terms, a plus and a minus, and you're left with a plus. So yes, it's valid. End A minus list C, would that be valid? No, you're left with a negative address. So what you should expect is a set of expressions. And then you're going to say valid or invalid. Circle what your choice is, valid or invalid. More on that Monday, we'll talk about it. Okay. And on the last page, we have program C. Again, XDEF, which means export to the symbol table, the global symbol table. XREF, import from the global symbol table. And you're basically defining these symbols so that when they occur in the source code, the assembler doesn't flag it as an error. It just puts a 0 for that because it doesn't know what they are. Okay. The last one, the last line, 42. It is a word, and the value of that word is 30, 48. Where did that come from? The 00030 0. Where did that come from?
Plus this C.
The list C, exactly. It's defined in this file, we know what it is, so we go ahead and give it the 30. Does everybody see that? Okay, good. So, I want to work on this now. I want to go ahead and modify all of these. So the first thing I want to do is write my global symbol table. This will make the whole process easier.